simple case today, although we have two parts and both of them should be addressed in your submission, but both of them are very similar, and the analysis also is really simple as long as you understand the marketing model. So the marketing model that we've got today is Bass diffusion model. So the definition of Bass diffusion model based on the lecture notes or the lecture slides that you have also access to them. It's a tool or it's a marketing metric or model that predicts how many people in the market will eventually adopt a product or adopt a service. So basically it's a prediction model that forecasts the number of people who adopts a product or a new service or a new packaging, a new design. So when we ask you to explain the methodology, we mean explaining this marketing model that you are applying. So this model is Bass diffusion model or simply Bass model. The definition is just a prediction tool to predict that the number of people who adopt the product in the market. So the components of model, we have like 3 components in this model, number of like the total number of people in the market, the number of innovators in the market, those that adopt product initially, and the number of people who are influenced by innovators, and they're called imitators in the market. So these are the components of the model. You need to know the components, and then when marketers apply this model, why marketers apply this model, what are the benefits, and of course, what are the shortcomings and disadvantages. So it's about the methodology. But in terms of the analysis for this week, we have a data set, including, I mean, like the first sheet includes a data set for 2 countries, China and India. These are the actual data from Euromonitor database showing the household mobile phone adoption in these 2 countries from 2000 to 2014. So we know that how many people adopted mobile phone in each country in these years. But what we have to do, we have to use the actual data for 10 years and then predict the mobile adoption for 4 years from 2011 to 2014, and then compare the actual adoption with the prediction adoption. Then we can find out whether the model is accurate or not. If the actual adoption that we already know, like the population who adopted the mobile phone, is similar to the prediction one, it means that the model is accurate or is precise. If there's a big difference between these 2 sets of number, it means that the model is not that much accurate because it was not able to predict the actual number, or not the actual, but like a number close to actual number of people. So it's about part A. In part B, we have the similar things kind of, but with less analysis requirements. We have the information for 4 countries, like they are in 2 big categories: West Asian countries, including USA and Australia, and East Asian countries, China, I think China, or like it is India or China. Yes, China and Indonesia. Comparing the mobile phone users like in these 4 countries, we have to calculate the Bass diffusion model parameters for these 4 countries, and then compare countries in terms of the mobile adoption and see if there's some differences between these countries, and then what's the cultural reflection. That, like, is it because of the cultural things or cultural differences across the countries that we have seen differences in their adoption or not. So it's a brief explanation of the case, and let's start analyzing the data. We have 2 sheets here. Let me just, I'm sorry, I think it's better to, sorry, I mute myself to remove all the created sheets from my previous class because I didn't want to, irritate you like by noise of just removing. Okay, so part A, adoption projection. So as I explained, we have two sets of data for two countries, China and India. They are actual numbers, but let's see actually what are these numbers. These are accumulative numbers or accumulative number of adopters in each year. If you look at the China for 2000, year 2000s, we have more than 32 million people who adopted mobile phone, like not people, households who adopted mobile phones. And in 2001, we have 64 million people, but it's an accumulative number. It means that like it includes the previous year mobile phone adoption as well. So we have the same analysis for China and India. We want to compare the application of Bass diffusion model for each country. So that's why I will do the both countries like at the same time. Then at the end, we can compare the prediction of model for both countries. So let's get a little bit more familiar with the parameters of the model. I know you have read the lecture slides, you know what are the parameters, but one more time as a recap, we have M, P, and Q as model parameters. M is the number of customers who will eventually adopt the product. So basically it's the size of the market eventually. And P is the coefficient or the effect of innovation, or the number of people who initially adopt the product. And Q is the coefficient of imitation, number of people who are influenced by innovators and adopt product later. We have AT and QT that they are not model parameters, they are model components. AT is the number of adopters in time T, and QT is the cumulative number of adopters by the end of time T. So you should be able to see my screen. If you can't see, just let me know. I'm on the Excel file now. So we have to perform 4 steps to reach the step of comparison. We have to estimate regression model to find the model estimation A, B, and C. And then we will use model estimation and calculate Bass model parameters, P, Q, and M, and then we forecast adoption, and then we compare the forecast adoption and actual adoption. So let's start with China and create AT, QT minus 1, and S squared QT minus 1 for China. So you have some reference equation in your data set as well. Bass model parameters are obtained from this regression. AT, which is the number of adopters, equals to A plus B multiply QT minus 1 plus C multiply S squared of QT minus 1. So if we get AT QT minus 1 and the S squared of QT minus 1 and run the regression, we can estimate A, B, and C. So with the actual data, we are able to find AT, QT minus 1, and QT minus 1 S squared. So as I mentioned, the data set that we've got is the accumulative data. To find the AT or number of adopters in 2001, if you find the differences between two cumulative data here, you find the actual adopters for 2001. So AT equals to, sorry, cumulative data for 2001 minus the year before. So it's just a subtraction function. And then for the second year, I need to do the same thing for 2002 minus the year before. Or it's not efficient. You can use the formula for the rest of the years, and it works well because we are in the same column, and we just change the rows. So there's no need to fix anything. You can use the formula for the rest of the column. Just to double check, one of the 80 here for 2007, it's a difference between 2006 and 7 cumulative data. QT minus 1. As I said, this actual data is QT. It's the cumulative number of adopters in each year. What we need is QT minus 1 in each year. Say in 2001, QT minus 1 means the QT for 2000. So just simply equals to the QT of 2000s. And then for the rest of the column. As you can see, the right cell is selected. For 2010, the QT of 2000s is selected. And then raise these numbers by 2. Just multiply this number by itself. It is one way. Or this number raises by 2. And for the rest of the cells. So basically, we are using with the 10 years of the data because we want to estimate parameters based on 10 years. And then based on this estimation and parameters, predict the adoption for the next 4 years. That's why you can see that the data is just for 10 years here. So do the same thing for India. And meanwhile, if you have any question, just feel free to ask. Okay, so we have the components of regression model. Looking at the highlighted part, I have highlighted the Bass model parameter regression. If I run this regression with the X range as QT minus 1 and S squared of QT minus 1, with Y range of 80, I can estimate A, B, and C. So just regression model. And then choose AT column as Y range. And both QT minus 1 and S squared QT minus 1 for X range. And because I have selected the label, click label and give it a go. So we have 3 coefficients here. The intercept is A, QT minus 1 effect is B, and the S squared QT minus 1 effect is C. And this number is not wrong when you see E minus number in Excel. It means that the data, the value is very small and Excel cannot read it. Like it is like 0. If I put this number as number instead of general, it is actually 0. But I want to have the actual number. So copy and paste